Excellent. Good afternoon. Thank you very much for joining us in today's session, Lessons Learned Running Linux Workloads in Azure. My name is Jose Miguel Parrela. I'm a PM in the Azure Office of the CTO. I'm joined today by my colleague Jerome, who will introduce in just a second. Before we begin, we just wanted to say thank you to a bunch of people, both at Microsoft as well as in the community that have provided references, input, and inspiration for this session. That includes people working with Linux-based workloads at Microsoft, including BanisDB, which is a Postgres cluster running on Ubuntu that powers pretty much all of the Windows release QA process, as well as, of course, external luminaries in the community, and our partners, community and commercial partners who have been slowly kind of documenting a lot of these lessons learned and best practices in their deployment scripts and their codified best practices on GitHub. We also would like to thank Andrew, who's a partner from the UK, who recently launched his AzureChecklist.com, which in a way is an inspiration for the kind of three big buckets of things we want to talk about, which are design, rollout, and operation of Linux-based workloads in Azure. So I'd like to introduce my colleague Jerome from Red Hat, because we're going to be relying a lot on his expertise as well as what we're doing with partners like Red Hat to make sure workloads, including SAP, OpenShift, and many others, run great on Azure. So why don't you go ahead and introduce yourself, Jerome?
So hi everyone, my name is Jerome Buto. I work for Red Hat on enabling Red Hat products that are certified cloud and service providers. So I've been working with Microsoft, Jose Miguel, and a number of other folks on enabling Red Hat products in Azure.
Let's talk a little bit about design and in particular right sizing and the implications that has down the line when it comes to Linux-based workloads. Do you want to talk a little bit about the considerations there?
Absolutely. So first, you don't want to end up with this scenario where you have a chair on top of a thing and then you have no idea when it's going to fall down, right? So it's important to think about design at the beginning when you first start going into the cloud and when you first start deploying your app. And you have a lot of decisions to make. But first, you should start thinking about workloads as the starting point. Don't think of individual virtual machine, but think of workload and what does it mean to actually support the workload. In the end, it's not about is the VM working well. It's are the customers and the users of the workload able to interact with the application or the service that you're trying to deliver. So first with that means where do you want to put the workload? Which regions? What location do you want to put the workload? And where is the data that the workload is dependent on located? Because if there's a certain challenge around data gravity that if you're far away from your data, you potentially are going to have trouble with the workload. And third part of the right sizing is the performance in selecting the right instance types that you need for that workload. So the things that you want to specifically look at is the storage performance, so the IOPS and the type of throughput that you'll be able to get, the CPU and RAM that are available on the virtual machine, and last but not least, the networking. And networking doesn't just mean the throughput that you can get from the VM, but also the relationship of all the different VMs and how their topology or networking or potentially networking to on-premise depends on each other. And the last part of this that's sometimes the most complicated is all these decisions actually have an impact on cost. And so, yeah, you could pick the biggest VM in Azure. And yeah, your app will probably work well. But guess what? It's going to be very expensive. So you need to learn and adapt and educate your workload as you deploy it.
I think there are families of VMs on Azure. You can pick storage optimized, memory optimized, compute optimized, etc. Some of those SKUs are kind of self-evident for the workload. Like if you're doing GPU or if you're doing memory-intensive kind of SAP-based applications, those will kind of be self-evident. But in some cases, we're going to look into general-purpose VMs as kind of our basic building block. And one of the interesting examples we recently worked on is sets of lessons learned running Cassandra on general-purpose Linux VMs on Azure. So something interesting that I wanted to show you is in the Azure website where you get to look into the specs of the VMs. Looking at this DS series VMs, for example, you see a critical distinction here. It has to do with the throughput for cache and on-cache disks. And you can notice that the cache disk does have lowered throughput. And that comes into consideration for the specific kind of testing we did in the case of Cassandra. The consideration is that there is a point at which, as you increase the number of threads for your Cassandra workload, you're actually going to see your latency hitting the cache, your latency is going to increase. And that's because you're kind of exhausting that cache because it has a lower throughput. Another interesting finding, and this is again with read-only cache, which is something that we see in the wild very often. By default, only the operating system disk has a read-write cache. So we see read-only cache very often. But another interesting finding from this work, which we're going to, of course, reference this in the resources, it's already on GitHub, is that the read-ahead values at some point can trigger throttling. So there's diminishing returns in terms of the operations per second you can get as you tune that value. So again, this is a clear example of that relation between the right sizing of the instance and looking at the details specifically of that instance specs and how the workload is kind of going to behave in a way. I want to talk a little bit about disks and file systems, but before that, I thought I would just show something I thought was funny. It's a recent paper, File Systems Unfit as Distributed Storage Backends. It has a discussion on why maybe looking at file systems as carrying them from legacy and into the cloud might not be the most appropriate thing to do. Interestingly enough, I was just looking at some of the authors for this, so that was pretty interesting. So talking a little bit about disks and file systems, we do see a lot of different file systems on Linux VMs on Azure, XFS, X4, B3 as well. But they're almost always dictated by the workload and or the vendor. It's pretty much the file system that comes with the image of whatever it is that you're trying to run, or is the file system that is supported by whatever the workload is that you're trying to run. However, pretty much everyone uses some form of disk striping, such as LVM or RAID 0. There are considerations on chunk and stripe size that are workload dependent as well. Something very interesting that we always say, and if you've ever contacted Azure support, it's one of those things like Serial Console that we always try and stress is the importance of addressing volumes by UUID instead of relying on specific naming for devices. All of these are little examples of what ultimately we're going to talk about, which is treating this units of compute as pets and as VMs that require very specific care. Disabling file system bearers is another interesting setup that we see on the wild, especially if you are not using a write cache, which again, as in the case of Cassandra, is the example. There are a number of popular mount options as well that we see that are related to performance. Reducing swappiness, so we're going to talk about tuned in just a second, as well as the I/O setting. We even see some of this, I'm going to call it backwards compatible, but potentially confusing setup by distro vendors. So if you boot up a Debian 10 VM today on Azure, you're both going to have the I/O scheduler set to something, and at the same time, we're going to use multi-queue setup, which kind of cancel each other, but in a way, it's a way to maintain backwards compatibility in case you're running an older kernel. I want to talk a little bit about tuned, because that is a way, very important in Red Hat world, to package some of these tunables in a way that is easier to swap. So I'm just going to show the profiling. Can you talk a little bit about that, Jerome?
Yeah, so we do a significant amount of work to build tuned profiles for the workloads. We do have a general case tuned profile for virtual machines, which is the default on the Red Hat images in Azure. That will work for most of the use cases. But then you do have targeted configuration you might want to do. So if you're doing a HANA configuration, your tuned profile will look different. Right? In-memory database doesn't need the same thing than a web server. Same is true, we have a tuned profile for a SQL server. And so we've built a fairly wide collection of tuned profiles that are available to you. And you can also customize it to fit the needs of your workload. The reality is, we can't create, a tuned profile for all the workloads out there. So your unique workload may need some slight changes to what we've built as standards. But these are a great starting point that you can then apply based on your needs.
Yeah. I think we also need to talk a little bit about what's out there beyond disks. And again, in this conversation of file systems as backends for distributed storage, it is important to revisit some of these things because they keep evolving. Blob storage is something that has been out there since the beginning of Azure, but the tooling has evolved. Today, we see more customers leaning towards newer tooling, such as blob transfer. as well as in some cases using a better supported and more active Fuse implementation of Azure Blob Storage. There are many things in the wild. If you go on GitHub, you're going to find a lot of people that are kind of implementing some form of interface with Azure Blob Storage, just like they would in other cloud blob storages as well. But the tooling has evolved, and certainly I still see many cases where people are using the Azure CLI for interacting with blob storage, which is fine, but you're going to eventually run into some limitations that some of these tools are overcoming. Azure Files is another interesting one that has been available for a while, but has previously kind of been intractable by Linux system operators. NFS 4.1 is something that's been announced at Ignite, support for Azure Files. So I encourage you to take a look into that. And I'm sure that, as many manage file services, it's not going to be a drop-in replacement, or, it's not going to always be equivalent to whatever it is that you have on premises. That's where there are many other solutions, including NetApp Files, as well as things that have their own affinity to container workloads or HPC workloads. All of those things, in some cases we have some write-ups, trying to shed some light on the performance and functionality of this, but in general, they're all supported on Azure. So all of this is part of the design phase, and we are already seeing that many of these partners and commercial products have been finding all these tunables, and in the case of TuneD, they're kind of, that you can group some of those in profiles. So already in the design phase, there are things that you would change in the VM model and things that you would change in the VM itself. So that kind of certainly has to dictate a little bit how the rollout is going to look like. And something interesting to me that I think is unique to the Linux world is that the discussion about rollout, provisioning, lifecycle, et cetera, kind of starts with updates. It kind of becomes the main pivot, like how are you going to update this thing? You might know what you're going to tune, you might know what you're going to run, you might know what your observability story is going to look like, but a lot of these architectural decisions start with how are you going to update? Can you talk a little bit about some of the considerations there?
Yeah. So what we've seen is there's there's a bunch of different paradigms for how to update and how to service the application. First, again, taking the view of a workload instead of looking at our individual VM, there's a bunch of different pieces of this of an app. There's how will you deploy the application? So how will you create the structure and then deploy in the wild? And the second part is the updating servicing, which is how do I get my new security update for this Heartbleed or whatever else comes out at some point? And also, how do I make sure I get advantage of potentially new packages that, let's say, a new version of Python or something like that? All of that has to be wrapped around with the proper automation so that it's easy to deploy, but also if you do want to do new tuning or maybe change from one VM to another VM because you want to actually go to a bigger VM or lower VM because of cost concerns or for performance concerns, you want to have that automation set up. So generally, servicing takes two different views. One is a little bit more of a pet approach, which is instance servicing. This is what you would do traditionally on premises, where you would have a running physical system, a running virtual machine. It runs. You want to do an update. In the case of Red Hat, you yum update. You wait, it updates, and then you update it. That's great for things that are persistent. So if you have something like a HANA database or something that's persistent, more than likely you will do instance servicing because you will treat it more like a pet. The second approach, which is quite popular, especially in the cloud, is image servicing, where you treat your application as a cluster. And instead of updating the individual virtual machines, you redeploy. So that requires a certain set of automation. And when you deploy your application, you basically point to a new image that you create. So you take your image, update it, that's your new gold image, and then you deploy or stretch your cluster. So if you have 5 nodes, you want 6 more, you can just have it deploy more nodes in that part of that cluster. That gives it the resiliency that it needs so that it can be up and running properly.
So Jerome, a question. So is instance servicing a bad thing?
No. Depending on the workloads, you might actually even be doing both. You might do image servicing to update to, for example, a new minor release, but do instance servicing to make sure you get the patch for Heartbleed.
So it means I can still, for example, plan to SSH into a large number of VMs to do things like a YUM update, like a major rel update in place, or an apt upgrade and Debian and Ubuntu world. But that feels like a lot of work. Is automation kind of a key thing here, whatever the servicing model you choose?
Absolutely, and you hit the nail on the head. Yes, you could SSH to the systems, but in the cloud, you're going to have a lot of these VMs. And you don't want to do it one by one. You have an application, it's not just one VM. You potentially have 100 or 1,000. And so you need to have a repeatable process that uses automation so you can do these steps. So the things that you want to do with automation, the goals that you want to have is you want to be able to have repeatability, which means being able to redeploy the app whenever you want. That could be redeploying in the same region, different instance type, different region. That automation will make sure that you can do that. The repeatability also gives you the ability to do updates in a practical fashion because you don't want to SSH into 1,000 systems. So if you have automation, you will be able to do that well. And I touched on this migration. So if you want to migrate from one instance type to a larger one or a smaller one in different regions, with the automation, it really is very simple, a matter of a few clicks of a button. The automation should be workload-centric. So don't treat it as automating one VM that you update. Treat it as you're updating the cluster. So what does that mean? So if you have a 5-node cluster, you would start with updating one VM so that if you need to roll back, you're not impacting the workload as a whole. And then you can do test dev process where you test the update, make sure it works well, and then actually scale it out to the rest of the cluster. There's a number of tools out there for automation. You can use the ARM templates out there. At Red Hat, we use Ansible playbooks and Ansible Tower. Ansible playbooks are a way to automate deployments, and Tower is a centralized console to manage all these deployments. And there's a few others out there, like Chef, Puppet, and the like, that are available for automation. The important part is that you think of this at the beginning of the step. If you forget to do automation and you have to build automation after the fact, it becomes a lot more work. So start at the beginning, and then all the tuning that we're talking about is easy to actually deploy.
Right, I was going to ask. So pieces like TuneD or OpenSCAP for compliance, Ansible playbooks, Chef, Puppet, whatever else you might have, that's part of your toolbox for automating the VM, and then ARM templates, et cetera, Terraform, other things would be how you describe the VM model, like the outside of the VM. I said something before. I said that this was especially important for Linux than for other operating systems. We hear a lot, and including in Red Hat kind of world, about packages, updating Flatpaks and RPMs, and all those different. There seems to be a lot of innovation, not just in kind of Red Hat world, but also in app world, et cetera. Does this change the picture in any way, or do we still think about instance versus image servicing, even with all of those innovations in package management?
The tool that you use to update will be unique to the distribution that you use. A lot of distribution will have different tools. But the high-level message around image and instance updating or servicing is the same. So to your question, no, it's not going to change anything because you can take a higher-level view, and that gives you a workload-centric view, which shouldn't matter what's underneath.
And what about release cadence for distributions that are just like rolling release or release faster than others? Does it change this? Does it influence this in any way?
It may, well, security updates obviously are going to be quite important, and these will come out pretty frequently. And then it kind of depends on the workload. It depends on the amount of downtime you're willing to take and how often you want to update that workload.
Right. Let's talk a little bit about high availability.
What?
High availability.
High availability. Yeah, so there's there's two different processes of doing this. At Red Hat, we have a technology called Pacemaker, which is to make a active, passive, or traditional cluster technology. So if you do have something like a HANA database, something that's persistent, you'd use a Pacemaker cluster, which allows you to have 2 nodes, and then the Pacemaker will cut off the connection between the 2 nodes to make sure you don't have a splintering scenario. And that's great for traditional workloads that you move into the cloud. So if you have pets type workload, that's what you would gear towards. Now, there's another kind of resiliency that comes in the cloud, which is basically clustering and using scale sets and scale groups to make sure that you can have an application that's using load balancing as a method to do availability. It's a different kind of availability because you're doing more load balancing availability, which relies on services and usually it's a first step into microservices to create this distributed approach to the application. You would end up with potentially, let's say, for example, you have a web server, you have a load balancer, and you, instead of doing an HA cluster, you would just make sure you have as many nodes as possible and use the same data backend so that any nodes that are trying to query the web server will be able to get access to it.
I think another interesting observation is that when we're talking about things like Kubernetes, it kind of already offers some of the higher level primitives that are interesting to care about when you're thinking about servicing all those Linux-based workloads. For example, the way the cluster is upgraded itself with the ability to cordon and drain nodes, or some of the considerations are less about is a yum update operation inside the cluster failing or not failing. You start worrying about other things such as are my tools going to be compatible with the API version of the new cluster or something like that. So definitely, if that's kind of like your entry point to thinking about this, because you're operating a Kubernetes cluster, whether you're running apps or Postgres or whatever it is you're doing there, by all means, kind of you can enter there and still use Azure Resource Manager templates and all these things to kind of shape the outside of that. I wanted to show a quick demo about custom metrics, and before, and in order to get there, I need to explain a couple interesting concepts. So there's one I would like to start with because it has some relevance to high availability, and it is, in case you're not familiar with instance metadata, it's an endpoint that's available to VMs on Azure that you can query for general metadata about the VM. In this case, I'm running a Debian VM, and I just query this, gets me some JSON back, and some of the information I can get back include, of course, host name and that type of stuff, but I get keys, I get custom data. If I've been using custom data, I get networking information. And one of the interesting things you can do in, say, a scale set or a cluster environment is you can use the fault and update domains to kind of shard a little bit your deployment. This is used on the wild today. I think DataStax Enterprise is a good example of a solution that uses instance metadata service and these values to kind of already do the, I'm not going to call it service discovery, but the initial organization of the cluster. And those are, again, some of the tools that are available to you. And we're going to see not just during the high availability cluster operations portion of it, but also in the provisioning. I'm going to talk about that in just a second. So another thing that this endpoint provides is service identities. So I can assign identity to this VM so that the VM or something inside the VM can perform operations back in Azure. So again, this is just another endpoint I can call, and I think this is the one. And in this case, I have already provisioned one, and I get a token back, and this token can be used by processes inside the VM to perform operations on Azure, and I can control that. So one of the things that one of the workloads that already uses this is Telegraph. So Telegraph is a metrics shipper, part of the Influx kind of family of open source projects, and Telegraph already has a piece of code in there that kind of sees, hey, I'm running in an Azure VM. I see that there's an identity here. Perhaps this user wants to ship some metrics to Azure Monitor. And because Telegraph already has a number of plugins, and I can show you that in just a second, if I can find where the code is. So I can show you some of the input plugins that are available. So very, workload specific, workload rich plugins that are available. And what I did here is I just wrote a small plugin for PSI, pressure stall information. It's a new kind of metrics facility in the Linux kernel that provides a little bit more of an anticipation for exhaustion of resources such as CPU, I/O, and memory. It is used in companies like Facebook to predict that a process might be running out of bounds and kind of kill it before the killer, the kernel killer kind of steps in and maybe makes the whole instance go into a fail state or something like that. So just very quickly, running this locally, dealing with latency here for SSH, running this locally, I see some metrics here. I'm particularly interested in this line because it contains the PSI information that I'm just going to extract. And this is running locally in the VM. But as I said, as soon as you install Telegraph with this plugin installed, it detects that identity and it connects to Azure Monitor, starts just shipping that metric. So that means I can literally just forget about the instance and work on dashboards. And I literally just created a dashboard that uses those CPU, I/O, and memory pressure information. And I'm comparing on the left is traditional Linux system load, on the right is PSI. So you see it's a little bit more predictive, it's a little bit more sensitive to some of these things. And of course, being Azure Monitor, not only can I do the regular alerting, including calling webhooks and that type of stuff, but I can do the auto scaling, not only of the VM, but of additional resources. So say in this case, I have an Azure Data Explorer cluster. Let's say, for example, it is kind of a bottleneck for my VM or something like that. So I can go here and configure a custom auto scale, and then I can add a rule. And then this rule can be on a different resource. It doesn't have to be on the Data Explorer resource. I can just search for virtual machines. I can find my VM, just here somewhere. And then in my metric namespace, you see many Telegraph kind of facilities. Here's the PSI one, and I can choose, whatever the CPU, I/O, whatever it is that I need. I can actually see a quick peek there, and I can auto-scale a different Azure resource based on that with minimal setup, which again goes back to the image-based servicing point that I can, for example, in an Ansible playbook, just provision the Telegraph, package, the RPM, the deb, whatever it is, and I can start acting on this custom metrics in the backend for things like auto-scaling or calling back my application or something like that. So again, it's an interesting way of using instance metadata service for high availability. But as I said, there's also a provisioning aspect of it. And switching back to slides, while you're provisioning a Linux VM on Azure, there are 3 endpoints that are useful for provisioning. There's a pre-network endpoint, which is basically a DVD you can mount that has an XML in there. You can parse the XML. You'll find things like expected hostname, username, keys, that type of stuff. It's there for backwards compatibility reasons almost, and it is heavily used. I'm going to show you code, open source code that uses that in just a second. There's also what we call the wire server. It's the thing that gives you DHCP replies to your DHCP requests, and then there's a metadata service that I just mentioned. Of course, you don't have to talk to or know that these things exist at all. When you deploy a Linux VM in Azure, whether it's Red Hat, CentOS, Debian, Ubuntu, et cetera, there's code in there, open source code, such as the Azure Linux Agent or projects like Cloud Init or Ignition, that will talk to these endpoints and will call the HTTP client or do whatever it is that they need to do. But at some point you're going to get into, when you're into image-based servicing, you're going to run into not having to deal with the software components, but maybe have your own that need to understand provisioning and need to understand that these things exist. We have seen customers in the wild doing things like what you see on the right. Their own little shell scripts called from a cron or a systemd unit or something like that talks back to the wire server and says, yep, I acknowledge that here's this XML document that says I'm supposed to do all these things during provisioning. Yes, I did all those things during provisioning. And then Azure says, great, you have a green light there and your instance is healthy, which is what we call internally in Azure reporting ready state. It's important also to know that it's possible to disable extensions. In fact, when you create a VM, there is an API kind of parameter for that. And it's also possible to run a Linux VM on Azure without the agent, which has been a requirement from some of you. Of course, when you call support or there's an issue with an extension or something like that, we might ask you to reproduce with the agent just to understand the root cause exactly what is that's happening. So I promised to show you code for this, which I think it's always valuable to know that you can go on GitHub, you can go on the Cloud Init project, and you can see a data source azure.py file. It's a Python file, and it has all the logic in here that includes, talking to instance metadata service. It's going to include things like parsing the XML file, getting the SSH keys, provisioning it to the right location in the file system. All of that kind of stuff you're going to find here. And it's always a good document to refer to. We maintain it, we contribute to it, but more often we have seen that oftentimes customers want to see the code and sometimes even tweak it for whatever provisioning purposes they might be looking at. I wanted to talk a little bit about tunables. This is arguably an area where it would be fantastic to have Microsoft kind of come here and say, here's all the 10 parameters you need to tweak, and your VM is going to have the best performance ever. But of course, there's not a lot of value in just copying over tunables from the internet. We do see, I can tell you what we see if you go on GitHub and you search for Azure provisioning scripts for Elastic or Cassandra or Postgres or Mongo, you're going to see some commonalities, and we've talked about a few of those. But it is almost always workload specific. We have recently seen people starting to get into things like increasing TCP send receive buffers, that type of stuff. The reality is that for most of your instances, 80% of the performance and the optimizations are going to come from architectural improvements that you make in your application. There is going to be latency outliers, and for those, that's where things get interesting. But you're not going to find that doing micro benchmarking, right? Like you're not going to get into those latency outliers and say, great, we're going to run a bunch of FIO or iPerf or any of these tools, and we're going to find out what's wrong. Oftentimes, you're going to observe what's wrong. And again, this goes back to the little demo I did with custom metrics and the ability to use some of these signals, including PSI, to try and understand where the contention is, and try, of course, always root cause the instance. Does this happen if I move to a different instance? Does this happen if we right size to a different instance? These are always good things to do. And of course, as I mentioned, just the ability to act before failure implies that you're observing the behavior of whatever it is you're acting on. So if you're looking at PSI because you want to kill processes before the killer does, then probably you want to have enough data of PSI to understand what is normal and what's a statistical kind of anomaly. I think it's important to talk about hardening too, and I'm going to talk about a few areas and lessons that I didn't find a better way to qualify this as trying to have some sort of affinity with what Microsoft does in managed services. We sometimes hear this, that we want to run our own VMs, but we want that to look as close as possible to the VMs where Microsoft runs AKS or HDA inside or something like that. And this is a very unique ask because it's not normal that, and especially for us, it's not normal that people are asking us, how do you run Linux at Microsoft? But hopefully some of this can be helpful. And the other thing is that if you are an enterprise Linux customer, with a commercial partner relationship with a company like Red Hat, you probably don't want to do what Microsoft is doing. You probably want to do what Red Hat, is supporting. So take this with a grain of salt, and I'm going to try and talk about a couple things that could be useful. One area is hardening. If you run AKS today, there are Linux VMs that we run as nodes for your Kubernetes cluster. We have received a number of requests to ensure that those nodes are CIS compliant, CIS hardened. There is no other way for us to do that than in the open. It's literally out there in the AKS engine repo. Every little thing that we need to tweak in those nodes to get one step closer to compliance, we got to do it in the open source repo. So literally you can go, the link there will take you to the board, the GitHub board, where we have all the pull requests related to CIS hardening, and you can see exactly what we did there. And it's a lot of shell scripts and things that you can use. So that's one thing. But in Red Hat world, there is an interesting approach to it. Can you talk a little bit more about that?
In our world, we use OpenSCAP, which gives the ability to have profiles, which uses OVO files for different security profiles. So we have, for example, STIG, and there's a set of hundreds of different profiles on the OpenSCAP pages, which enables you to have an image or a system that's built to match the security profile that's needed for that use case. So for example, for PCI compliance or such, we have a profile that will set up the system for you. You just need to run the profiling tool.
Yeah. Another example I would like to bring to the table is, hey, we're going to run some Linux VMs to do some pre-processing or some post-processing around our HD Insight cluster. We therefore would like to run the same Java you run in the HD Insight cluster. Is that possible? The answer is yes. The OpenJDK we run in HD Insight and a number of other services, Spring Cloud, et cetera, is the Azure Zulu OpenJDK. And Azure provides a Zulu build for anyone on Azure, any customer, multiple versions of it, again, 11, 12, et cetera, and in different formats, including container format, if you would like to just work with containers, as well as native package format. Again, this is another great example of, if you're running Red Hat, Enterprise Linux, do not install this, because Red Hat already offers you an enterprise-grade OpenJDK that is actually supported.
Yeah, we ship it with the OS, so if you do want to install OpenJDK, you can enable the repo and yum install the OpenJDK. It's fully supported, it will update with patches, just like we do for any other packages that are part of the operating system.
And another example would be Movi. Movi engine, Docker container runtime. Again, it's the runtime you're going to find in places like Azure Container Registry. If you're doing builds on Azure Container Registry, that is on Movi. So sometimes people tell us, hey, we want to run that in our test environments, which are Linux VMs as well. Can I get the bits? Yes, you can get the bits. Those are on packages at Microsoft.com. You're going to find the Movi engine and the Movi CLI both there. And again, these are just two examples, but we oftentimes get this type of request from our customers. And although there was an excellent session earlier today on Azure Tune Kernel that we're going to reference on the resources part of this session, I just want to highlight that when you run CentOS, Debian, SUSE, Ubuntu, you run uname-a, you're going to see we're running, or they're running an Azure-specific build of the kernel. And the way those are built, the config, the specs of that are all in the open. And it's a joint definition between Microsoft and our partners. And again, it delivers a number of performance improvements and optimizations at the kernel level for all of these images. Was there a question? Did you have a question? Oh yeah, yes. I guess that we have a PowerPoint version that's too advanced for my ability to control it. And one last thing that might sound a little bit, like it's a minor thing, but we hear a lot from customers, has to do with timekeeping. I kind of classify customers in a number of categories here. Some customers want to have the same time as Azure. Some customers want to have the exact time, which is a hard problem. And some customers really just want to have, even if it's the wrong time, they just want to have the same time everyone else in their cluster has. So right now there are a number of solutions out there. If you're running Linux on Azure, and again, not any specific distro, you could be using pool.ntp.org, you could be using Red Hat's NTP servers, you could be using Canonical's NTP servers, you could be using no NTP at all. You could be using NTPD, you could be using Crony, you could be using systemd times syncd. And so I just wanted to let you know that we have documentation on this that explains what's available, and that we offer, if you see in your VM, you see a dev PTP0 device, that is the PTP clock you can use with a tool like Crony. So literally install Crony if it's not available, and if it's not already installed in the system, add that line, and then systemd can continue kind of managing the time and date of the system, but it will do the time sync using that PTP device. And the documentation that covers both this device as well as general NTP is available on docs.microsoft.com. You'll see the link in just a second. Before we open it up for questions, I just want to share a couple things. This space is changing. It's continuously changing. Here are, just like the file system paper, here are two recent paper and commentary on this. The way that we have dealt with recent vulnerabilities in the kernel has impacted performance, and there's been some research on this. The file systems and the way they will evolve in distributed systems is another area where we're going to see changes. So there are many moving pieces. I think the list of tunables and things to consider continues to grow, which is not good news because it's more cognitive load for all of us. But I think the core concepts, and particularly around automation, image-based servicing, remain, and that they will only become more and more important as these things continue to evolve. I wanted to make sure you know of 4 sessions, including one that is tomorrow that focuses on NFS if you're interested in that. There was a session earlier today, focused a lot on platform features, specifics on managing and securing Red Hat Enterprise Linux. Jerome will help us with that session too. Custom Linux images. I showed you kind of like the very granular pieces, raw pieces that you should be aware of if you're doing custom images, but we have a service called Image Builder that can help with some of that. And then NFS, as I mentioned. All of the pictures and links that you see there are going to be in the deck, so you can click in all of those. Let's open it up for question, but not before reminding everyone that evals are really, really important, especially for topics such as Linux in a Microsoft conference. It's really important for us to understand if this is valuable, if you'd like to see something change in future Ignites. So please take the time. We really appreciate it for your input. Let's see if there's any questions that you'd like to ask to Jerome or me. When do we get a Red Hat image in Azure China?
Well, so you can today import an image into Azure China. Today, there's no way to buy a RHEL subscription in Azure China, so we're limited by the ability to do that in the marketplace, but we're having discussions about it. So I don't have a time frame to give you right now, but those are discussions. But if you do want to get going, there are ways to import an image into Azure China so you can have the OS there.
Another question we got earlier today related to that is we have a list of endorsed distributions, and we were asked what's the next big distribution coming there. We're always listening to your feedback on this. There are endorsed distributions, and then there are things that run on Azure, 2 different categories. We see a lot of excitement around things like Clear Linux or around things like Kali that are not endorsed distros but run on Azure. But again, keep the feedback coming. I want to share with you a resource that is easy to remember, and you can start using right now. Linux@microsoft.com. You can send us an email, whether it's, hey, this is not working. Hey, I got this error message. I understand what it is. Hey, here's our current situation, and we'd like an additional set of eyes here. Or, when can we run RHEL in China? Or when are you going to get the new release of something in particular? Feel free to reach out. There's a number of stakeholders across the company that will read your email. It's not a replacement for support escalations, but it's definitely a channel for you to send us feedback.
So what's the percentage of Linux VMs running in Azure right now?
The question was, what's the percentage of Linux VMs running on Azure today? And it is more than half of VMs running on Azure today. Boris?
Yeah,
Yes.
I can attest to that answer. So I'm a Microsoft person. So we have more than half. We don't really report the number like to down percent, but it's more than 50% now. We reported 50% somewhere in the.
Yes. And yeah, correct.
Yeah, as far as monitoring, are you guys suggesting to use the Telegraph?
The question is, as far as monitoring, are we suggesting to use Telegraph? It is an option that's available and it's supported. There is some additional kind of rail guards and richness in the actual OMS kind of extension mechanism. And then the interesting thing, again, because of affinity, that's what Microsoft service teams use we use the native kind of Azure Monitor way, not Telegraph, to do our monitoring. So we're trying to invest in a couple places, and Telegraph is definitely one of those. For custom metrics, the only other alternative you have here is kind of crafting an API request, which is not a, I'm a sysadmin, so like, if I can curl it, great. If I need to write like error handling,
How about the BSD running on Azure? They don't support backup monitoring, that kind of thing.
What is it? What is it again? Sorry.
OpenBSD, FreeBSD.
Oh, OpenBSD or FreeBSD. It's Josh here. So FreeBSD runs on Azure. You want to?
Once, but not more.
So FreeBSD images are available in Azure now with Hyper-V support and Azure support, but your question was more about monitoring, right?
Monitoring or Azure backup?
Yeah, we don't have any specific things that we've recommended for either of those, but you can use anything you want. It should work.
If you're not able to make an Azure image backup, for example.
Make an image backup?
No, you're not able
Right.
to run Azure recovery services.
Yeah.
Because all the
Extensions
extension.
are for Linux. Correct.
Yeah.
Yeah, I'm sorry to not be able to offer a BSD at Microsoft.com, but send your feedback to Linux at Microsoft.com, and we'll make sure that the Linux fans don't delete it. And it gets, I mean, yes, there is the BSD integration services, which we build and maintain, and I think it's resourced, but you're right, you know, and you'll probably find more than one Linux system in our extensions that is something for us to think about. So thanks for the feedback. And you had a question too, sir.
So is there a high percentage of people using Ansible for configuration management on those Linux boxes?
Yes. Yeah. It is very significant, and we don't monitor usage, or you might, we don't, I think, but we do for Terraform, and we know that Terraform is also very significant. Yeah, they can potentially complement each other, but we see a lot of people interacting with the Azure management endpoints through Terraform rather than through APIs, et cetera. Yeah. Good. Okay, if no other questions, thank you again for your time, and enjoy the rest of Ignite.
Thanks a lot.